Hello guys and welcome back. So now we're going to take a look at how we can create this look here, which has this translucency effect to it, and it's being used here as well. You can see the translucency effect, and I think in the clip as well. Yeah, this version. So we're going to take a look at that. You can see we have a very interesting shadowing happening. And this technique is very, very powerful, especially if you want to render foam or translucent particle like this. It definitely works quite well. And this algorithm, this raise algorithm, is very known for rendering shadows using something called depth map shadows or deep shadows. And what these shadows do, what this method does, it's a very, very old, it's probably the oldest shadowing method. For each light, it generates a Z depth from that light. So the closest object will be white, the furthest object will be black, but it's not a black and white map. It accumulates the samples, so it's transparent. So this sample knows about the one behind it, and so on and so forth. And it uses that information to generate shadows, basically, from that camera. It projects that depth map shadow through the camera and figures out what's shadowing what and things like that. But the main advantage of this method is that it can render a huge amount of points or complex data independent from the data, because it's all converted into pixels. Okay, so it can render very fast the motion blurred data or anything like that, or heavy geometry, without having to use a huge amount of memory or anything like that. It's just a Z depth pass that needs to be generated per light. So what I'm going to do is I'm going to show you guys how to use this method. And let me find something. So I'm going to create two point lights or spotlights, and this is what the method works best with. Let's go back. Let's leave this here, it's fine. So I'm going to create a point light, and then inside this point light I'm going to turn on spot, and that will make it converted into a spotlight. And I'm going to transform it, copying previous values. And I'm going to rotate it. And now I'll show you the orientation. So this is the location of the light. Okay? It's probably too far from the object. Actually, let's leave it at that location. So I'm going to call this spotlight main, and then I want another one for the fill. So I'm going to copy the same light, call this spotlight fill. Almost there. And this basically is facing the reverse direction, or this side, so it can eliminate this properly. Let me check one more thing. Okay. Okay, cool. And I think I'll need to move this light. What we can do is we can look through the light itself. So I'm going to go and look through the fill light, and I'm going to lock the camera, and we can do it properly. So something like that. So I'm going to increase the cone angle, so make sure the light hits all the points. I'm gonna drag and drop this in the viewport, and that will set it to be the viewable light as well. I'm gonna zoom in here, and let's increase the cone angle as well. Make sure everything is encompassed inside this. Pardon me. And then inside, under the shadow for both of these guys, I'm going to change this to depth map shadows. And here you can see we have the resolution, which is the still image or the Z depth pass or the depth map pass. All these names are correct. And I'm going to set this to 1024 for both of them. And here you can see there's depth motion blur. So if you have an object that is motion blurred, and you want to render a motion blurred shadow for that, you have to take this on. This is going to be expensive to have this feature, so I'm going to leave it off for now. And let's go to the cam 1 and let's lower the shutter time back to 0.5. Okay, and now we're going to create the shader. Now for the shader, I'm going to use something that is not meant for points. So let's call this diffuse or wall isotropic. And what we can do is we can shade these points using a volume shader. Let's go to the matte. Or actually, this is going to shade the points using a volumetric method, but on geometry instead. So what we need is we need to create a lighting model, and inside this I'm going to set it to isotropic volume. I'm going to connect the surface color, the BSDF. Let's create a compute lighting just to be organized. And let's connect the function. Okay. I'm going to leave everything to the default. I'm going to set the ambient color to 1. And I think that's pretty much it. Let's just assign this to the object. And let's lower the settings a bit. Let's hit render. And let's take a look and see what we get. Cool. So it takes a little bit more time for it to come up, and the reason for that is because it takes time to generate the depth map shadows, and it looks like it's not rendering. So I'm gonna set this to render only points to make sure that it's rendering points only. And let's take a look and see what is this. Let's go here. I'm gonna connect the color. Oh, I see. I think it's because of this, but I'm gonna connect the surface color and the BSDF only. And let's hit render. Trying to find the what we can do for this is we can open Houdini from a shell and then tell Mantra to print out the render progress to the shell, and that way we'll see the rendering of the shadow maps going first and then the lighting of the points. So it looks like the shading is working. Now we're getting the alpha channel. Before there was no alpha channel, so it's better. And I'm going to debug this quickly, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.